Okay, so this video is the fifth part of the Streamlit tutorial series, where I go into detailed step-by-step on how you could build a data science web application. And so let's have a quick recap. In the first part, I have shown you the first web app that you could build using Streamlit in Python. And with that application, you're obtaining data dynamically from the Y Finance library, where it will retrieve stock data directly from the Yahoo Finance. And then we're gonna make a simple line chart. In the second part, we have built a simple iris predictor where we employed machine learning algorithm. And in the third part, we used the machine learning algorithm to classify penguins into one of three species. And so the concept is similar to the iris predictor, but with a notable difference in that the input parameters have three additional ordinal or qualitative variables. So that required a little bit more data preprocessing in order to encode the ordinal features into binary form. And in the fourth part, I've shown you how you could deploy your data science web application onto the cloud so that other people and your friends can have access to your data science web application. And we did that by deploying the application onto Heroku. And so today it is the fifth part of the Streamlit tutorial series, and we're going to combine two prior videos in the development of a web application today. So essentially we're going to dynamically retrieve data from the internet by doing web scraping of the basketballreference.com website. And so after we have web scraped the data, we're going to do some data filtering. And so all of this will be done right inside Streamlit. And so finally we're going to perform a simple exploratory data analysis by creating a simple heat map. And so all of this in less than 70 lines of code. And so without further ado, we're starting right now. Okay, so the code that we're going to use today is called basketball_app.py. And upon opening the code, we're going to see this. So all of this code is less than 70 lines of code. And so this is also including empty spaces as well. So if we are to delete all of the empty spaces, I would think it is approximately 60 lines of code. And so a lot to be done here, and it will occupy just a few lines of code here. So the data science web application that we are building today is called the NBA Player Stats Explorer. And so before we take a deep dive into the code, let's try to run this code and let's have a look at the web application. So let's close the file for a moment and let's open up a command prompt. So if you are on a Windows, type in CMD. If you are on a Mac or a Ubuntu, you want to open up your terminal. And so this is only going to work on my computer because I'm going to type in conda activate dp, dp being the name of the conda environment that is installed on my computer. So if you have a conda environment installed on your computer, you can activate that particular conda environment. So you could type in conda activate and then the name of your environment. For example, if the name of your environment is my env, then you would type in conda activate my env. But because on my computer it's called dp, I'm going to use conda activate dp. And so the lengthy explanation is due to prior videos. I have been noticing that there have been some misunderstanding that you will have to type in conda activate dp, which is not the case because if your computer is using just normal Python, you could just proceed with following the tutorial here. However, if you're using conda, then you will want to activate your own environment. Okay, so let's continue. So now I have activated my conda environment. I'm going to change directory to the desktop and then to the Streamlit folder, which is where all of my data are residing in. So for your case, you want to change the directory to where all of your files are located, particularly for the Streamlit tutorial. So the links to this code will be provided in the description down below, so you want to check that out. Okay, here it is. So the name of the app is basketball_app.py. So a point in note, for the first time that we're running this basketball application, you will see some error message, and the error message will tell us that some libraries are missing, and so that we will have to install the prerequisite library in Python. So let's have a look at this together so that we could overcome this error together. Okay, so you want to type in Streamlit run basketball_app.py. And so we're going to see this pop-up browser. And so here it says that XML not found, please install it. So let's close this. And then we are going to install LXML. Conda activate dp pip install LXML. Okay, so it's installed. Let's head over back. So notice that I could type fast here because I type in the first few characters of the folder name and then I hit on the tab button. And so the tab button will auto-complete the folder name. For example, I type in Streamlit run BA or just B and then tab. It'll auto-complete the name for me. Let's run the application again. Okay, so it seems to work now. And so this is our NBA Player Stats Explorer web application that we are going to build today. So let's have a look at the general characteristic of this web app. So you're going to see that on the sidebar on the left, we're going to have 3 input parameters. So the first one is the year of the data that you want to have a look at. And then the second parameter will be the team. And so notice here that you could select multiple teams, and by default, it will select all of the teams for you. And then you could take on the teams that you don't want, and then the results will be updated on the fly. So notice that whenever I click on the X mark here, you will see that the number of rows will reduce, right? From 683 to 665. And so the third parameter of the input is the position of the players. So we're going to have the 5 traditional positions here: center, power forward, small forward, point guard, and shooting guard. And so to the right here, which is the main panel, so here we have the name of the web app and then some description, and then we're going to have some header here followed by the description of the data dimension, and then we're going to display the data frame of our data set. So this data set will be downloaded spontaneously from basketballreference.com, and so we're going to use pandas to do the web scraping, and then it will do some simple data filtering. So I'm going to show you in the code in just a moment. And so once we have done some simple data filtering, we're going to display the data accordingly. And the data frame that you see here, we will be able to export the data as a CSV file. And finally, we will also have a look at the intercorrelation heat map of the input parameters. And so this is the exploratory data analysis that I have mentioned. So we're going to do only one plot here. So please feel free if you want to explore by including other data visualization plots in your web app. So in this web application, I made it so that the heat map will be hidden unless you click on the button. And upon clicking on the button, you will see the heat map coming up. Okay. So pretty cool, right? So let's now have a look in the code, shall we? Let's open up the Atom editor. File, open file, and then basketball app. All right, so let's have a look at the code side by side. Okay, here. So in the first 6 lines of the code, we're going to import the necessary libraries. So we're going to import the Streamlit library because we're using Streamlit to build the web app. We're going to import pandas because we use pandas to handle the data frame and also to perform the web scraping. We use the base64 library in order to handle the data download for the CSV file because it's going to encode the ASCII to byte conversion. And so finally, we're using matplotlib, Seaborn, and NumPy in order to create the heat map plot. Okay, so let's have a look further. On line number 8, st.title is the name of the web app, and the name of the web app is NBA Player Stats Explorer, which is right here on the right. And then some description of the web app is provided here. So you will notice that we're using Markdown language. So this description here will correspond to this line. The 2 bullet point will be corresponding to the 2 asterisks here. And the bold text will be corresponding to the 2 asterisks here. And so we're also including the data source link, which is basketballreference.com, which is where we are downloading the data. And so the following code here are for the sidebar. So this is the header name of the sidebar. So we're using the st.sidebar.header. And then in the input argument, we're using user input features. which is right here, user input features. And then in the following line, on line number 17, selected year is the name of the variable. And then we're going to use this line of code here to display the years that we want to see the data for. So we're making it as a drop-down menu. So we're using the select box function. And so as the input argument, the first argument that you see here is the name year. And so year is right here. So if we change this a bit, save it, and then we say always rerun, and then you're going to see that the question mark appears as well. So if we take it out, save it, have a look back, then the question mark disappears. Okay, and then the following input argument here is we're going to create a range of numbers. So we're going to have 1950 until 2019, which is right here. And then we are going to reverse the list of the numbers because it's going to start from 1950 and then 1951, 1952, and then at the bottom it will be 2019. And so I use the reversed and then convert it into a list in order for it to display 2019 at the top, right? Otherwise it will display 1950 at the top, and then it will be the default value. And so notice that whenever you change the year here, the corresponding data frame will also change. And so all of these data are downloaded on the fly, on demand, upon clicking on the input parameters. So nothing is stored locally on the server side. Okay, and then in this block of code here, it will be performing the web scraping and also some data pre-processing. And this is taken from a previous tutorial video where I will also provide the link in the description of this video as well, where we perform a simple web scraping of the basketballreference.com website. And then the only thing that we're using for the web scraping is only one line, which is pd.readhtml. So it's going to read the HTML file, particularly the data is in the form of a table. Therefore, pandas can easily read the data from the table, which is inside the HTML file. And then we're going to use it by dropping some of the redundant header, which is present throughout the table data. And then after removing those, we will perform some simple deletion of some index column here called RK, because it will be redundant with the index provided normally by pandas. And then finally, we will display the pre-processed data. And then on line number 29, we're going to make use of this custom function, load data. And then the selected year is the input argument, which is the variable here, selected year. So the custom function, load data, will retrieve the NBA player stats data by using the input argument, which is provided in the selected year variable. And the selected year variable is accepting input from the drop-down menu here. So whenever you say 2019, the value of 2019 will go into the load data 2019, which is the input argument. And so we're going to retrieve the data for 2019 and etc. for other years that are selected. Okay, so lines number 31, 32, 33, we're going to allow the user to select the teams that we are going to display in the data frame. And so line number 32 is the variable called sorted unique team. And so here we're going to use the player stats data frame, particularly the team column. And then we're only going to display the unique values. Okay, and then after that, we're going to sort the team alphabetically, and then it will be displayed here, right? Starting from A until W here. And then on lines number 35, 36, 37, we're also going to allow the user to select the positions. And so here we have specified the 5 traditional positions. Okay, so let's have a look at the import argument of the Multiselect function. So this Multiselect function will allow us to display all of the possible values inside the team variable and the position variable. And the second and third input argument here will be telling the Multiselect what are the possible values that we are going to be using. So the second input argument here will be using all of the team names and all of the position names as provided on lines number 36 and 32. And then the third input argument for both of them, we're going to also use as default value, which we will be displaying here, to be the same thing. So essentially, we're keeping the second and third argument to be the same. So this means that we're going to display all of the possible values in here. So let me show you. What if I do a simple slicing of only the first index number? So I will be showing you only one position, which is the first position, right? Here, center. So if I do the same thing here, I'm going to show only the first team, which is Atlanta, right? So here, you're gonna see that the options are showing only one value. So if I change this to 2 or 3, just some arbitrary number. And so you're gonna see that these arbitrary numbers that I have provided will show you the input values as the default. So if I just say everything, we're gonna use everything. So therefore, the second and third will be the same, okay? So let's save it, okay? So here we have all of the possible values. So let's say if we change the year to 2018, you're gonna notice that it's gonna be loading the data for the first time. And so it will say running load data function. However, if we switch back to 2019, where the data has already been loaded, and so it will use the catch data. And so if I switch back to 2018, the data has already been loaded just a few moments ago. And so the data will be instantaneously displayed. However, if I select 2017, where the data has never been loaded before, it will load for the first time, and you're gonna see running load data function. And then it will catch the data, okay, right here. In the line 20, we're using the @st.catch before the load data function. And therefore, whenever we select a new year, it will run for the first time, and then it will make a catch of that data. So that the second time we make use of it, it will be performing much quicker. And all of the underlying data will be updated as well. Filtering data. Okay, here. Let's have a look on line number 40. So line number 40 will be filtering data based on the input selection in the sidebar menu. So if we select Dallas out, Denver out, Chicago out, Cleveland out, then these resulting input will be dictating which rows to be shown. And so you're going to notice that the data dimension will be updated to be 512 rows now. And so if we take away some of it, then the number of rows will be impacted here. And so all of this is possible because of this filtering data part, which is line number 40. So whenever we make a selection on the sidebar, it will be in the selected team variable right here. And also in the selected position variable right here, which is corresponding to team here and position here. So whenever we update the selection, the data frame will be updated because the selected team variable and the selected position variable will be updated. And so we're also going to only filter the data and show only the remaining input selection. Okay, and so all of this is possible by this line. So I might make another video about selecting data in pandas. So you could do this by using the name of the data frame, and then you use a bracket, and then inside the bracket you put in your condition. Okay, so this is very powerful, and I believe that for those of you working with data wrangling or data cleaning, then this filtering capability here will be immensely useful for your project, particularly when you are preparing your own data set. All right, lines number 42, 43, and 44 will be displaying the header here and also the description of the data dimension. And it will be showing the data frame itself right here. So it will be showing this DF selected team data frame, the one that we have done filtering on. Okay, and then lines number 48 through 52, it is a custom function called file download. So the resulting data frame that we have here, we're going to put it inside the file download as the input argument, and therefore it will create this link for us, download CSV file. So notice at the bottom that you're gonna see a long generated code here. And so this is made possible by the base64 library. And so it's gonna perform some encoding and decoding, okay? And so all of this will be inside this function. And so this function is brought to you by the wonderful discussion in this Streamlit how-to, okay? And so let's have a look at the heat map. So lines number 56 until 68 is the heat map right here, where we click on the button and then it shows the heat map. It is possible by this if statement. If st.button, and then we have the name of the button inside as the argument. And then we have all of these lines of code as the underlying code. So st.header is the header here. So it is right here, the header. And then we're going to have df selected team, saving it into a CSV file, and then we're going to read it back in. And so the reason is, why are we doing that? Because I have been trying to create the heat map using the df selected team, and it's not working. And upon exporting it out as a file and then reading it back in, it read perfectly. So I think it has something to do with the data type that is inside the pandas data frame. But upon reading it back in, there were no issues. Okay, and so then we performed some intercorrelation matrix calculation, and then we created the heat map. And using this line of code here, we created this heat map where half of it are not shown because they are masked. Okay, so if you're finding value in this video, please give it a thumbs up, subscribe if you haven't yet done so, hit on the notification bell in order to be notified of the next video. And as always, the best way to learn data science is to do data science. And please enjoy the journey. Thank you for watching. Please like, subscribe, and share, and I'll see you in the next one. But in the meantime, please check out these videos.